I would like to introduce Professor Catherine Pelachaud, currently Director of Research for the French National Center for Scientific Research. The work conducted by Professor Pelachaud has brought together different fields: computer science, information science, and cognitive psychology, to mention a few. Professor Pelachaud has been very prolific in her research career, the author of numerous scientific papers, book chapters, edited books, also a co-organizer of conferences on intelligent systems and virtual agents. Most recently, she has co-edited a handbook on socially interactive agents, together with Birgit Legren and David Traum. And indeed, Professor Pelachaud is an expert on virtual agents and a number of communicative behaviors that can be generated for these agents, from facial expressions to gestures and even touch.
So facial expression, gestures, posture, voice, touch, and all that. And all those nonverbal behaviors have a lot of different functions. They can communicate intention, they can carry propositional contents, they manage the interaction, so turn-taking that. They also are there to for internal regulation, for example, to manage cognitive load, and also external communication, so for example, to show different social attitude or interpersonal relationship. There also, you can use different type of nonverbal behaviors to express yourself as real or desired self, okay, which can be linked to personality or expectancy to conform to some social norms. And they can also be used to deceive the others. So you can see that the broadness of those functions make the creation of nonverbal behaviors extremely difficult. Okay, so to create those social emotional agents, I mean, you often start by looking at work that has been done in different fields, like in psychology, linguistics, so, cognitive science, and all that. So what do all those terms like intentions, goals, engagement, emotions means? What are all the different factors involved in those concepts? As well as you want to look into data to see what is happening. I mean, to look really how the different signals are emerged and how they perceive and how they evolve through an interaction, for example. So I'm going to show you several things that where we were involved in developing Opera, because one of the important things is acquiring data like everybody else. So one thing that Emilia database was captured with mock-up systems, and we wanted to see how everyday gestures can carry signature of emotions. Okay, so we ask actors to perform very simple action like moving books, walking, knocking at the door, sitting down, while communicating emotions. If that. Okay, and after, of course, all those databases that you do, you need to validate them. We also using quite a lot of this Noxy database that involved two persons facing with each other, and they have to exchange information. One person knows quite a lot about the topic, and the other one wants to learn about these topics. And we've been looking at this corpora here for nonverbal behaviors, but also how they can be engaged or
parce que à la fois, il y a beaucoup de monde, mais à la fois, c'est splendide. Tu vois,
you can see, for example, the quality
combien de litres d'eau qui passent là, tu vas juste en bas et tu vois ces énormes chutes qui tombent devant toi, tu es trempé jusqu'aux os.
And another one we've been working on is on laughter. Laughter is an important social signal that we use quite a lot, and laughter can be there to show hilarious laughter when it's a joke, but also to show social groupings, or also irony, or sometimes it carry also propositional content. So laughter is very important. And here is only on hilarious laughter. And you will see how the interaction between the different participants of the data. No, that's good.
C'est de faute faire rire, c'est lui qui a rigolé.
And so you can see how people are, the whole body moves and that, but also how the audience saw this. Voilà, gazing at, okay? So we're looking at, and that's another one, SIAs came for doing job interviews. Okay, so once you've got those data, I mean, those you can see there was quite a lot of things happening in all of the data, you need to go and annotate them. So one of the first things is, for example, to annotate the vocal tracks, F0 or different voice quality parameters, but also to annotate, for example, when a person is doing given type of facial expressions, head gestures, movement, and the different tools that can do that. But sometimes it's not, you don't get everything on data. And one thing that we've done, and that was before we had all those tools doing signal analysis, is to create your own corpora, okay? And we created a toolbox that was Magali Ock's work, where she wanted to study different types of smile, like embarrassed smiles, nervous smiles, felt smiles, and things like that. And she asked participants to manipulate different set of parameters that involved only formational parameters. For example, opening of the mouth, symmetry of the mouth, tension in the lips, and also is a cheek phrase and things like that. And like that, people could, by just simply manipulating, they could create the smiles that they wanted. So in no times, we could have also data. And on this one here is where we wanted to look at social attitude and how you can convey social attitude for different dialogue acts. Okay, so it was the same. Participant manipulated, chose different value of the facial expression, gestures, amplitude of the gestures, and head positions, and things like that, to convey a given dialogue act with a different type of social attitude. But that was done almost 10 years ago. And lately, we were able, with the new tools that arise, and especially a machine learning approach, we were able to change how we carry on creating corpora. So I'm going to present some work where we wanted to model interpersonal attitude in virtual agent. And interpersonal attitude can be defined, and that's a definition we chose by Klaus Scherer, is that defined as an affective style that is spontaneously develops or is strategically employed in interaction between persons, coloring the interpersonal exchange in that situations. Such an attitude can be represented in along two dimensions, friendliness and dominance. Okay, and one thing what is very important is that from the definition, you can infer that a social attitude is not represented by just one expression at its apex, but as a sequence of multimodal signals, right? So how can we endow the virtual agent with to convey different type of social attitude as sequences of multimodal signals? So what we wanted to do is to study the variation of social attitude. So why a person appear more dominant or less friendly through its nonverbal behaviors, okay? So the way we've done it is that we start from a corpora and we annotate this corpora along two streams. One, which is on the nonverbal behaviors, So for example, the type of head movement is doing, the type of gesture doing, smile, posture, gaze, and all that. And we annotate also on a higher level here on the different dimensions of attitude. So dominance, level of dominance, or level of friendliness. So we can see that in one, we have like discrete emotion, like for example, if you have a head nod, head shake, a smile, no smile, type of things. While on the level of attitude, we had a continuous representation, and that captures the variation of perception. So once we have that, we extract where the behaviors that co-occurred during a change of perception in the attitude dimension. Okay? And from that, we got a set of sequences of multimodal behaviors that coincide with those change of dimensions. And we can apply the temporal sequence mining to extract the most frequent sequences of multimodal behaviors. So like that, the system can learn the temporal patterns that can be linked, for example, with a dominance increase or a dominance decrease, etc. All right. And after we can integrate the patterns into a virtual agent and evaluate it. Okay? And it's what we've done. So I can show you two examples. Here we have a dominance increase.
We will contact you within 1 week to let you know what we have decided.
And dominance decrease.
In your previous professional experiences, what made you the most proud?
Okay, so the behavior of the agent were computed automatically using those sequences of behaviors. And once we got all those different animation, we ask participants, we're conducting an evaluation study, and we ask participants to evaluate different videos of the agent saying the same sentence, either as a neutral behavior. So, I mean, what do we call it neutral? Is the version of our algorithms, our models of agent platform, I mean, before integrating social attitude models. And we asked participants, we had also videos that shows an increase or decrease of dominance, an increase or decrease of friendliness, okay? And it was a comparison task, so neutral versus different type of attitude. And participants had to evaluate how they perceived the virtual agent using 16 adjectives. And those 16 adjectives were taken from Larry's work that they put those adjectives in an octant and along the friendliness and dominance dimension, okay? And by that, you can see that there is, we can see that there is some correlation, positive or negative correlation, depending on how people are perceived. For example, in dominance increase, people will be perceived as more forceful, aggressive, defiant, and distant, while in and being less cheerful, less helpful, and less warm. So you can see that there is some correlation, some relationship between that a change in the dominance dimension also have impact on a change in the friendliness dimension. Okay, so as it was mentioned, lately I've been working on another type of modality that has not been so much studied or less studied in the field of virtual agent, and it's called touch. So we're through the work with Fabien Boucaud and my colleague Indira Tuvna, we're looking into social touch. So we want to undo virtual agent with the ability to be touched by humans and also to touch humans, okay? And touch is very crucial and important social signals. It can have also different functions like attracting attention, managing turn-taking, showing comfort, encouragement, and things like that. And in this work, we're particularly interested to develop decision models that would allow the agent to decide when to touch the humans and also with which touch for which function, okay? And we wanted, of course, to evaluate the decision models and touch acceptability, how humans, participants accept to be touched by a virtual agent. So I must admit that this study, it was not the simplest study to conduct during lockdown, and especially in using VR setting. So that was, yeah, we had quite a lot of bad surprise and had to revise our plan. But nevertheless, one thing that you can see in the literature, and we're also conducting our own studies, that touch can communicate different types of emotion, okay? And you can see that also by using multimodality, you can change also the perception of touch. And just by also changing, as I don't see if you see me, but by changing, for example, some physical parameters of the same movement, for example, if you're doing like that, or if you're doing like that, the same movement, but for example, with different velocity, you will change the perception of touch and you will attach different emotions to this type of touch. Okay? So we wanted here to see to what extent can touch help a virtual agent to express emotion and also to create bonds with a virtual agent. And as I said, we wanted to determine when and how to touch. Okay? One thing that is very important is to take into account the notion of touch acceptability. So touch is very cultural dependent. We know that. I mean, there's a lot of studies that shows it, but also there's a lot of interpersonal differences. Some people would accept to be touched, some others will not accept to be touched. So the virtual agent will have to pay particular attention to this touch acceptability. So the work is the model as it is. So we have the agent is able to build a mental representation of the users, and we have also a model to detect when the agent is touched and where it is touched and which type of touch it is done, and is also able to touch through a certain device. So the perception of touch is done by using colliders. So it's work that was provided by Nguyen and Bachschmutz more than 10 years ago. So you put some colliders on the virtual agent, and we, like that, we're able to understand where the agent is, which part of the body part the agent is touched, and after the direction of the movement. So we don't have, for example, intensity that we doesn't have it in our system. The decision model. So once you detect that there's a touch is happening, so the decision model has been implemented in an emotional model, Fatima, that is developed by Diaz and Ana Paiva's group in Portugal, and it takes the decision models take into account the agent emotional states. It's also take into account some information it got about the state of the situation, and also information it has on the users, okay? And also, as the interaction goes on, the agent built a perceived perception of the rapport that is being created between the agent and by the users. So the agent, as the interaction goes on, takes into account users' reaction and to infer if rapport is being built or not, or being enhanced or not between the users and the agent. We also have this notion of static touch avoidance to capture the fact that users may not like to be touched or not. And so the decision models, we decide based on the type of communicative intention you want to convey, and based on those information, if the agent should touch and which touch it should convey. Okay? So again, we evaluated such models, and this model was developed during a lockdown. So it was absolutely impossible to go to the lab and to do any user studies. So one thing that was done is by doing use case simulation. So it was you define a scenario and you have your systems, your models go through the different steps using different initialization, okay? So for example, here we can model that the agent, the humans, simulated humans had to perform a memory games. And the idea is that if he felt, it was meant that he was not paying so much attention. And if he's not paying so much attention, it's not creating rapport with the virtual agent. And that will imply that the agent's emotions may decrease, and the agent may, for example, also decide to grab the attention of the users. So we could capture all those, we could simulate all those things by varying some of those initial parameters. Lately, we were able to have to start working on, and we conducted another study, and we were hoping to go in the lab, but there was a second lockdown, and so we changed. So we went from having the device, I want to show it right after, to no device, and rather than having a cave where we could have humans interact with the virtual agent, we had a 3D virtual environment where the humans are representing through an avatar here and the virtual agent here. So the scenario, there was a discussion between the virtual agent and the agent about the experience of the lockdown. So there was quite a lot of encouragement and reconfort types of touch going on. Okay? So it's in French. But...
Et au restaurant ou dans un bar. J'ai vraiment eu du mal à vivre tout ça au début. Le premier confinement a été très dur. L'isolement et toutes les régulations des sorties, ça m'a miné le moral. Comment ça s'est passé 2020 pour toi? Pour moi aussi, c'était très dur. Surtout que j'étais confinée dans un tout petit appartement à Paris. C'était hyper dur pour se sentir bien. Ça plus l'inquiétude de ne pas savoir ce qui allait se passer ou combien de temps ça allait durer. J'ai même eu des soucis avec l'appartement. C'était hyper inconfortable. Je suis passée près de la crise de nerfs.
Especially since the users came closer to the agent. Okay, so the agent could infer that the rapport relationship was fine to use touch. Okay, so hopefully for the third try, we'll be able to use a cave environment and also to use a device to simulate touch. So we created, as a work of Maxime Grandidier, we created an apparent using voice coils to modulate the different frequencies of the voice cords that are attached to the upper arm, lower arms, to simulate different type of touch. So that system could be validated, and is able to simulate different type of tap, caress, hit, and things like that. Okay, so now we really hope that we'll be able to have a real interaction between the virtual agent and humans in a cave. Okay, so one further work I wanted to introduce is adaptation mechanism, and I see how far I can go to describe that. Is that during an interaction, there's quite a lot of things that is happening between participants, okay? And you have one thing that you have quite a lot of synchronization, imitation, back channeling, and all that. And here we want to build socially interactive agent that is able to optimize engagement. For example, if his role is to be museum guides, and it should provide as much as possible information to users, or it should give proper impression to the users and all that. Okay, so we work on undoing the agent with different adaptation mechanisms. Okay, an adaptation mechanism can be imitation, verbal alignment, synchronization, and all that. So one thing that we looked at, the parameters that we could manipulate for the virtual agent is social dimension of social cognition, warmth, and competence, where warmth can be linked to sociability and morality. Okay, while competence can be linked to different types of competencies, cognitive competence, which is linked to knowledge, functional competence, which is linked more on skills, and social competence, which is linked to relational skills. Okay, and here we focus mainly on sociability and social competence in our work. So we're conducting 3 different studies where we built an interactive architecture of a virtual agent that can interact with a human. And we created one scenario where it was the agent plays the role of a virtual guide, and he was giving information about an exhibit that was happening in the museums. And so we had 3 different adaptation mechanisms. Okay. So here's the overall architecture. So we have the humans interacting with the agent. We have information, verbal and non-verbal signals of the user being analyzed and interpreted that are fed to the dialogue manager that decide what the agent should say. And we have those adaptation mechanisms. So the scenario, as I said, is a virtual guide. The location is the largest museum of science in Paris. And there was at the time, in conducting the experiment, an exhibit of video games. So the agent was there to provide information about this video games exhibits. The participants were all museum visitors, and the protocol was always up. When they started the experience, they first answers a pre-questionnaires about NARS, which is a questionnaires about a priori attitude of the participants. And after the participants interact with the agent, and they feed out post-questionnaires, okay, on how they perceive the agent and the interaction quality. Okay, so the first models was on adapting the type of non-verbal behaviors you can do. And the models that we done is based on reinforcement learning. That means that we wanted the agent, his aims was to appear either more competent or warmer, and we wanted the agent to learn which non-verbal behaviors it should display in order to enhance the impression it provides on the users. So the reward function was a detected impression of the users, and those detected impressions were developed by Wang and Al from the University of Geneva. and is based on the analysis of the facial expressions, while the agent at each dialogue tools will select how to convey communicative intention through different type of gestures, or iconic gesture, or beat gesture, rest position like that, or arm laying down along the body, using a smile or not, and different type of verbal. Should it be more formal, less formal? Should they use a pronoun I, you, we, or something like that? And so we're conducting the models, and we found that we couldn't find any significant differences in the warmth condition. However, when we consider the notion of people that have positive a priori, participants did find the agent warmer when it was in the warmth condition than in the other condition. However, we didn't manage to change the point of view of the negative a priori participants. And we found for the competence condition, we did find a significant difference. So I will speed up. In the second study, here we wanted to work at the conversational strategies. So no longer on the nonverbal behaviors, but also how you're going to convey a given intention, okay? And for that, we rely on the conversational strategy defined by Jones and Pittman, where defined, for example, to enhance the perception of warmth, you could use ingratiation or simplification, where simplification, you may lower your competence level, and you have the same thing, self-promotion, intimidation, okay, for the competence dimension. Okay, so again, we're conducting a study where we ask participants, they were going through one condition at a time, and after we found that there was a primacy of the warmth condition, that in the supplication and ingratiation condition, the agents appear warmer, while in the self-promotion, we had the same level of supplication and ingratiation. So somehow there's an halo effect with competence, the self-promotion. You have a better, higher level of perceived competence, and that will increase the perceived level of warmth, okay? While for the intimidation, you lower your perceived level of warmth, and indeed the agent appear much colder. The last one is at a very different level. There, we wanted to capture the interactive loop that is happening between participants. And we wanted to take into account, like when you have two participants communicating with each other, they adapt their behaviors sometimes very rapidly. And we wanted to capture this interactive loops that is happening at the signal levels. So we wanted to build models that take into account the behaviors that was done by the users along time windows, and the agent behaviors that happened during these time windows that we computed to predict what the agent should do in the next time frame. Okay? So for that, we used prediction models, and is based on LSTM. LSTM is an approach that allows you to model sequentiality and temporality of nonverbal behavior over times. So as I said, it takes into account this the behaviors that we have here that we consider. So smile, we just consider upper face, and smile, activity, head rotation, and gaze. From and output what should be the value of those 4 features for in the next time frame. So we learned the models on a corpora of human-human interaction, okay? And like that, after, we could apply it to our virtual agent. So as input, our system here, the adaptation mechanisms goes no more on the dialogue manager as speaking terms, but really at the signal level. So we take into account the user's signals and have an implication on the behaviors models, okay? So it has to take into account users and agent behaviors, and output the agent models. And we again, we found that there was some that in this, when the agent adapted its smiles and the world behaviors, the agent appear more friendly, more involved, and less distant, and more, but more satisfied. Okay, so to conclude, sorry, I speed up because I saw the time was flying, that we're conducting 3 different studies to more different aspects of adaptations. And we need to, of course, incorporate much more modalities, especially on the verbal and vocal side. And we need to model so different complex phenomena that we haven't taken into account, such as rapport buildings or empathy. Okay, so just as a conclusion, I show you our work towards undoing social agent with variety of nonverbal behaviors, and also how they can be undone with adaptation mechanisms, and also using touch modality. Thank you.